We're going to be going through trigonometry with regards to calculating the value of an unknown side. I'll read the question. Correctly label the sides of the triangle or of the following right angle triangles and determine the value of the unknown side x. In each of these examples, the unknown side I've called x. Now, as we spoke about earlier, the first thing that we need to do is label our triangle. And with the first example, example A, this triangle I've already gone ahead and labelled, okay, just as like an example to the others that we're going to do. We've labelled our hypotenuse side as being opposite the right angle and also the longer side, which leaves our opposite and adjacent side, which we need to figure out. Okay, our opposite side is going to occur opposite the angle in the question. Here's our angle in the question, therefore our opposite side is there, leaving our adjacent side remaining. Adjacent meaning next to the unknown angle, or next to the angle in question 50 degrees, therefore 7 metres is next to 50 degrees. Thus it's adjacent. Okay, once we've got our sides labelled, we then need to define the trigonometric ratio that we're going to apply. And in this instance we're using tan. The reason why we're using tan is we note the values in the triangle that we have. Okay, we have an opposite side of an unknown x and we have an adjacent side of 7. So to identify what rule we need to use with regards to sine, cos or tan, we note we need to use a rule or a ratio that's going to incorporate the opposite and the adjacent side. Okay, soccer toa, T-O-A, O and A, there's O and A, T referring to tan, therefore we're going to use our tangent ratio. So we express that as tan theta equals, as we said, O divided by A. Alright, once we've established that, it's then just a matter of substituting those values of theta, being the unknown angle, okay? Theta refers to the unknown angle, 50. O refers to the x, and A refers to the 7, okay? So I've just substituted in that particular line up here with regards to the values that are given in the question. Once I've got that done, I then need to solve for x. Now to get rid of a divided by 7 on the right hand side, I need to times by 7 on the right hand side, and that would get rid of my divided by 7. But if I times by 7 on the right hand side, I must times by 7 on the left hand side, which is why I've said 7 times this tan 50, okay, which is equal to now x, because we've eliminated that divided by 7 by doing that step there. Okay, to get rid of the divide 7, we simply times it over the other side. 7 times tan 50 equals x, which if you put into a calculator should equal 8.34. The units are metres, they're given in the question. Okay, now these first 3 questions that we're going to do, A, B and C, I'm going to try to go through them pretty quickly. A, B and C, all you'll note have an unknown numerator. That's what this says, okay? Unknown numerator, which basically means x is on the top, okay? Note, x is on the top. So for these 3 examples, A, B and C, x is always going to be on the top. Examples D, E and F, I'm going to have x on the bottom. So you've got every single variation for these trigonometric ratios, okay? The next one, question B. We have another right angled triangle. We're given an angle, so you know, sweet, we have to use trigonometry. We've got an unknown side and we've got a given side. First thing, label your triangle. Hypotenuse occurs opposite the right angle. Opposite side occurs opposite the unknown, or opposite the angle in question being 60, so there's our opposite, leaving our adjacent remaining. Okay, once we've done that, we know what trigonometric ratio incorporates an adjacent side and a hypotenuse. Alright, I know the answer to that. It's going to be our sine rule, our cos rule I should say. Therefore we write our cos ratio being cos theta equals adjacent on hypotenuse. Thus A and H. Okay, theta represents the angle in the question. Theta in the question is 60. A in the question is our unknown x, which we've substituted as the numerator. As I said, these first 3 are going to have an unknown numerator, so x is on the top, like I said. Divided by h, h is 14, and we write out, or substitute our 14 in. We then need to get rid of this divided by 14 on the right hand side so that we've got x by itself. To get rid of a divided by 14, I have to times 14 to the other side of the equation, which is what I've done here. 14 times this cos 60, which is up here. Okay, that will get rid of that 14 from the right hand side, and I've then got x by itself. If I plug this into a calculator, I'll get the answer. Therefore, x equals 7 centimeters. Okay, I've got the units back up from the image. Question C. Once again, this is another unknown numerator. We've done a tan, we've done a cos. You can probably guess that we're going to do a sine now. Question C. Here's our angle in question, which is 30 degrees. If you can't read that, it is 30 degrees. Our unknown x and a value of 19. First step, label your triangle. Opposite the right angle is our hypotenuse. Opposite the angle in question is our opposite side, leaving our adjacent as a remainder. We then note what trigonometric ratio do we have to apply that utilises an opposite side and a hypotenuse. As I said, it's going to be sine, seeing that we've done a tan and a cos. So we write down our sine ratio. Okay, sine theta equals opposite divided by the hypotenuse. We then substitute into the rule. Theta in the question is 30, therefore we substitute 30 for theta. Opposite in the question is x, therefore we substitute the unknown x, divided by the hypotenuse of 19. To get rid of a divided by 19 from this side, I have to times by 19 to both sides, okay? Which is why I get 19 times sine 30, providing me with just this unknown value of x, okay? And if I multiply 19 by sine 30 in a calculator, it will give me 9.5 metres, or 9.5, and the units metres come from the question. That is your sine, cos and tan trigonometric ratio with an unknown numerator. That's all good and well, but 50% of the time you're probably going to get an unknown denominator. So I've even gone ahead and done another 3 quick examples. I'll go through them just as quick. I'll probably actually go through this next one a bit slower than the remaining 2, just so you can sort of see the process. Alright, let me slide this down. I've got to try to keep these hidden. Alright, now this question D is going to be the first of the questions where we're actually utilising an unknown denominator. Okay, so first step, label your triangle. Opposite your right angle is your hypotenuse. Opposite the angle in the actual question, which is our 40, is our opposite side, and leaving a remaining adjacent side, which is our unknown. Once we've done that and labelled our triangle, it's a matter of recognising what trigonometric ratio utilises O and A, or the opposite and the adjacent. It's our tan ratio. Therefore we write our tan ratio, tan theta equals opposite divided by adjacent. We then need to substitute into that particular formula, theta being the angle, 40, and opposite being 12, with the adjacent being the unknown. Note this line here, compared to example A. They are both examples of tan ratios, okay? But the difference now is your unknown is a denominator, which means you have to do a little bit of a different rearrangement, and this particular setup where your unknown is a denominator does throw people off, which is why I want to go through it. Okay, now what we want to do here is we're trying to find x. So we want x by itself, such that x equals blah blah blah, and we got our answer. Okay, but at the moment it's 12 divided by x. What I would like to do, just like with the last problem, for instance, if I got rid of this 7, divide by 7, to get rid of the divide by 7, I have to multiply 7 to the other side. Okay, I can do exactly that with this one.
X times 10.
Absolutely, except with, instead of a 7, we're going to use the x. So what I'm actually going to do is multiply this side by x to get rid of it. But if I do that to the right hand side, I have to also do that to the left hand side, which means I've now got x times tan 40 equal to just the 12. And hopefully you can recognise once we're there that I can simply get x by itself by dividing 12 by tan 40. If I divide this side by tan 40, you'd agree that tan 40 would disappear. Okay? If I divided this by tan 40, we'd lose the tan 40 and just be left with x. Same thing here. If we do that to the left-hand side, we have to do it to the right. Therefore, if we divide the left by tan 40, we've got to divide the right by tan 40, which gives us 12 divided by tan 40, leaving our unknown x. If you put that into a calculator, you'll get 14.3. Units go back up to the question and you can see they're in metres. Okay, so that's an example of an unknown denominator using the tangent ratio. The next one is obviously unknown denominator, except now we're using cos again. Okay, looking at the question, there's our triangle, where our angle is 35 degrees. We have an unknown x for the hypotenuse and this value of 22 centimetres. Label your triangle first. There's our hypotenuse. There's our opposite, leaving our adjacent. Once we've got that, we know what trigonometric ratio utilises h and a, being the hypotenuse and adjacent. It's going to be cos, okay? Cos theta, a divided by h, or adjacent divided by hypotenuse. So we write that. Once we've written that, we substitute into the formula. Theta is the angle in question, which is 35 degrees. So we substitute 35 for theta. A is 22 and h is x, which is what we have there. Just like with the last question, we're going to do the same process. I want to move this x to the other side, but to do that, I need to multiply by x on this side. If I multiply this side by x, I have to multiply this side by x, which is why I get x times cos 35. Therefore, the x has disappeared from here because x divided by x is 1. We don't need to write that. Okay, so we've got our x on the left-hand side now. Oop. Got our x on the left-hand side now. So to get x by itself, what am I going to have to divide 22 by?
Cos 35.
Cos 35. And we get x equal to 22 divided by cos 35 in a calculator is 26.9. The units that we need to attach is centimetres. Last question. Once again, unknown denominator, but now we're doing a sign question, so we've got an example for every single one. There's the shape. I've tried to orientate these triangles all wishy-washy so that you sort of have to really look at what sides are what. You can't just copy it from the previous question. Label the triangle. Opposite the right angle, H. Opposite the angle in question, O. Leaving our adjacent side next to the angle 50 degrees. What ratio utilises hypotenuse and opposite sides? It's our sine ratio. So we write that out, and then we substitute the values for theta being the angle 50 degrees, opposite being 18, and the hypotenuse being x. We then take x to the other side. Okay, if we've got divide x on this side, to get rid of it, we need to multiply x. If we multiply this side by x, we'll just get our 18, but we also have to multiply the other side by x, because what we do to one side, we need to do to the other. Thus, x equals sine 50, x times sine 50 equals 18. And then to get x by itself, I simply need to divide 18 by sine 50 to get rid of that sine 50 from the left-hand side. And we're left with something that looks like that. In a calculator is equivalent to 23.5. The units from the question are metres. And we're stopped.